Alrighty then, folks, moving on to example number 5 now. We're going to solve this rational equation. And our first step, as we've done in the previous examples, is we want to first find the domain. And so we set each of these equal to 0. So x minus 2 equals 0, which means x equals 2, and x equals 0. So I just set this equal to 0. And so we have two values, x equals 2 and x equals 0, which means that if x were to be 2, or if x were to be 0, that would make the value undefined, right? And so that's why we say that our domain, and that's why we always first find our domain, is all values of x such that x is a real value where x is not equal to 2 or 0. Okay, so that cannot be true. X cannot be 2 or 0 because it's going to make the value undefined here. Okay, so now let's go ahead, and so that's step 1. Now let's go on to step 2 now, and step 2 is to find the lowest common denominator and multiply everything by it. Well, our lowest common denominator is just going to be x times x minus 2. Okay, because if this has an x minus 2 and this has an x, they don't have anything in common, so all you gotta do is just multiply by both of them. So I'm gonna go ahead and multiply everything by that common denominator then, okay? All right, so and the way that I'm gonna do it, I'm gonna kind of do it similarly to our previous example, and that is, what does this need so that we have a common denominator of x? So I need to multiply this, by x times x minus 2. I'm going to multiply this top and bottom by x. You see that there? Same thing right here. What do I have to multiply this by so that I have x times x minus 2? Well, I have to multiply this by x minus 2, right? X minus 2. And what do I need to multiply this by so that it's this common denominator? Well, just x, right? Times x times x. And I like doing this method because basically, look, the denominators are exactly the same. X times x minus 2, x times x minus 2, x times x minus 2. When you have the exact same denominator over every term, you can just ignore the numerator and just write down the denominator now. 2x times x is 2x squared. Negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. Well, and this should have been equals right here, by the way. Equals. And then 4 times x, positive 4x. Okay? And so now, simplifying this now, I'm going to go ahead and just combine those guys together. So I have 2x squared is equal to x plus 6. Okay? I'm going to move these guys over to the left. So I have 2x squared minus x minus 6 is equal to 0. Okay, so I just move this by subtracting x on both sides and by subtracting 6 to both sides. So now our goal is to still solve for x, so we want to go ahead and factor this now. And let's see here. Let's see here. If we're going to factor this guy, I have to get 2x squared, so I'll put 2x and x. And let me see here if I can figure this out at this time. I guess that would just be x, 2x. Let's see, that would be a 3 and a minus 2. Let me see if that works out. It's 2x squared, so that gives us negative 4x, and that gives us a 3x. Yeah, so that gives us negative x, right? Because negative 4x plus 3x is that, and then 3 times negative 2 is negative 6. Good. So now set each term equal to 0. 2x plus 3 equals 0, and x minus 2 equals 0. And if I solve now for x, minus 3 on both sides, divide by 2, so x equals negative 3 halves, and then I'm going to add 2, so x equals 2. Great, so now we have two solutions. Okay, and now let's just go back up to our domains that we found up here, our domain where we said that x cannot be equal to 2 or 0. Do you guys see that right there? X cannot be 2 or 0. And that means that when we come back down here, this solution right here, we have to eliminate, because this is what we call an extraneous solution. Meaning that we found a solution, but if you were to plug in it, we would get an undefined value. It's not even possible. So we cross that out, and we would say that x then is -3/2.